Okay, this is page 597, one of the book problems, number 75. We're talking about healthy bones. The recommended daily allowance, RDA, of calcium for women between the ages of 18 and 24 years is 1,200 milligrams. Researchers who were involved in a large-scale study of women's bone health suspected that their participants had significantly lower calcium intakes than the RDA. To test this suspicion, the researchers measured the daily calcium intake of a random sample of 36 women from the study who fell in the desired age range. Minitab output below displays the results of a significance test. Now, Minitab is just a software program, and remember that the majority of the college-level teachers out there that teach statistics don't encourage the graphing calculator. Instead, they use computer software programs to analyze statistics. So the College Board needs to ensure that students know how to read computer software output. So here's an example. It says test of mu. That's your funny looking u, the mu, equals 1,200. So it's saying that your null hypothesis is mu equal to 1,200 and your alternative is less than 1,200. Gives you the variable, n is your sample size, gives you the mean, so x bar, your standard deviation, that's the s sub x, the standard error of the mean, which we really don't need because we'll run this in the well, actually we don't even need to run this in the calculator because it gives our t-scores negative 6.73 and our p-value 0. So do these data give convincing evidence to support the researcher's suspicion? Justify your answer. And then part B, interpret the p-value in context. Well, I still probably need to go through and do my state, plan, do, conclude. So looking at the data, which you hopefully have your book out and you're looking at it in front of you as well. Number 75 for my state. Look back at the problem. We're looking at the mean amount of milligrams that 18 to 24-year-olds consume. So they measured the daily calcium intake of a random sample of 36 women. So for the state, the mu is the average daily intake of calcium of women ages or between the ages of 18 to 24 years. And even though they put in the computer output the actual HO and the HA, I'm going to rewrite it here. It says mu equals 1,200 and the alternative says that mu is less than 1,200. And then for the plan, don't know if it's going to be checked or not for grading, so I'm going to go ahead and do it. The problem tells us that we have a random sample of 36 women, which is more than 30. These are the nice problems. Less work to do. Both conditions are checked. Now we say with conditions met. We can apply t-distribution and do a t-test for one sample mean. So the do part, they already have all of our info. I'm just going to rewrite it. we have our n equals 36, x bar is 856.2, the s sub x is 306.7. You can write the standard error of the mean. That's just the 306.7 divided by the square root of 36, I believe. It's 51.1. Then we have our t-score, negative 6.73, and our p-value, they said was basically 0. Now you could plug all that into your calculator. You don't need to, but you would highlight statistics and put in the info. Now for the conclude, with a p-value equal to 0, which is lower than alpha equal to 0.05, we can reject the HO. We have convincing evidence. Now this is where you can cheat, look back at the actual part A and copy what it says. We have convincing evidence to support the researcher's suspicion. And that's all you need to say. You can say more about it, but sometimes less is better. Part B, this is really all they probably wanted for Part A, but it was good practice to do all the rest. Part B, I want you to interpret your p-value in context. And that is if the null is true, if the HO is true, then there is a 0% chance of obtaining a sample of 36 women age, was it 18 to 24, that consume 856.2 milligrams of calcium on average. And that was just the sample results in context, which I probably could have reread the question and wrote exactly what they had. Alright, so that was it for number 75. We need 77. And looking at 77, I know I'm going to need some extra room. So a new piece of paper here. 77, I'll read that one to you. Pressing pills, interesting. Drug manufacturer forms tablets by compressing a granular material that contains the active ingredient in various fillers. The hardness of a sample from each batch of tablets produced is measured to control the compression process. The target value for the hardness is the mean equal to 11.5. The hardness data for a random sample of 20 tablets are listed below. There's only 20, so in the back of your mind you should be thinking, I'm gonna have to graph these. Is there convincing evidence at the 5% level that the mean hardness of the tablets differs from the target value? So we have to do that whole 4-step process, state, plan, do, conclude. So here we go. The state, remember this is 77, and we're looking for the target value of hardness is mean of 11.5. So we're really, the mu is the average of something in the parameter. the average hardness in the tablets, the average amount of hardness in tablets I think that's good enough. We don't want to write too much. The plan, and then we need the HO is going to be that it equals what it's supposed to, so mu equals 11.5. And the alternative, what's he trying to think? Is there convincing evidence at the 5% level that the mean hardness of the tablets differs? Differs means not equal to. So your state part is done. The plan. Let's look back. Did he have a random sample? Yep. Random sample of 20 tablets. And I went ahead and put all of these numbers into my L1 already. You can take a moment, hit pause, and do that yourself. But I put them all in, all 20 of them. And I'm going to need to make a histogram, and I've already selected that for my y equals for my L1, so I'm just going to hit graph. I did play with the window just a tad bit. Since all these values were 11 point something, I needed to focus on what I wanted to count by with decimals, so I chose 0.1, went from 11 to 12. And then the graph, wow, look at that, pretty symmetric. I'm going to hit trace so I can see we're starting at 11.3 and going up to 11.8. So I can copy that down real quick. I'm seeing that it's roughly symmetric and unimodal, so I'm happy. I'm copying that down on my paper. Just going to put the starting range, 11.3, and the ending range, and then the size of each bar above it. So then I'm going to put the hardness levels, instead of saying the data are, I want context, are roughly symmetric and unimodal. And then with the conditions met, we can use the t-distribution. With conditions met, we can apply the t-distribution and do a t-test for one sample mean. So the do, I'm going to go to my calculator, run the test. Got my data. I'm looking for it to be 11.5 for the mu sub 0. My data is back in L1, and I'm looking for not equal to, so calculate. There it is, 0.772 is my t-score. P-value is 0.449, so going to fail to reject. Do, copy down all that information. T-score is 0.772. P-value is 0.449. X-bar 11.5164. Standard deviation is 0.095, and my sample size was 20. And then I'm going to go ahead and do a curve as well. I'm going to go back to the t-test, and instead of calculate, I'm going to do draw. And see what it looks like real quick, because we'll see some cool shading going on. Remember, it's not equal to, so both ends of the curve are shaded. Even though our statistic fell only on one side of the 11.5, I mean, it was slightly on one side of it, which is why we're failing to reject. So if you're going to copy it down, make sure you shade both ends. It's just kind of like back up with your work and everything to have it. This t-score would be positive 0.7 or negative 0.772, and the one on this end would be positive, and the p-value together is 0.449. So each of these are half of that 0.449. But back to the conclude. With a p-value excuse me, equal to 0.449, which is greater than alpha equal to 0.05, we fail to reject the HO. We do not have evidence that, and remember, you can cheat for this part and look back at the actual question. A lot of times they spell it out for you, and they do. It says, is there convincing evidence at the 5% level that the mean hardness of the tablets differs from the target value? No, we do not have evidence that the mean hardness of the tablets differs from 11.5, or you could write the mean target value. Did not ask me to interpret, so I don't need to. Done. Alright, that was the book problems, 2 problems at least.